Welcome ECO151 students to week 5. During this week, we will cover the concept of elasticity in 3 sessions. The first session will focus in depth on the price elasticity of demand, whilst the second session will illustrate the relationship between price elasticity and the revenue structure of a firm. And then the last session will discuss other demand elasticities as well as the price elasticity of supply. Demand and supply curves are amongst the most valuable analytical tools in economics. This stems from the fact that these curves help us organize our thoughts logically as we explain economic phenomena, predict the likely effects when an economic variable has changed, as well as analyze the effects of policy decisions. From the prior 4 weeks, you have acquired some important basic principles of supply and demand. At this stage, you should be able to analyze with certainty the likely effects of a change when either the demand or supply curve change, or both curves changes simultaneously. However, knowing only the direction of change is not sufficient for our analysis. That is, we need to know to what extent did the curve shift and by how much did the quantity demand or quantity supplied change. Thus, we are more interested in the magnitude of the change. Furthermore, for us to be able to make informed economic decisions, we need to know how responsive is quantity demand or quantity supply to a price change. In simple terms, we need to know by what magnitude does quantity demand or supply change following a price change. More technically, we can say we want to know about the price elasticity of demand or supply. In this first session, our discussion will be structured as follows. Firstly, we will define elasticity, followed by an in-depth analysis of price elasticity of demand. As we proceed, you need to take note of how the elasticity of demand is calculated using the point and arc or midpoint method. Elasticity is a measure of responsiveness or sensitivity. That is, when two variables are related, we often want to know how responsive or sensitive is the first variable to changes in the second variable. For example, the size of maize crop depends on the rainfall, ceteris paribus. But then, if we experience a drought in the Western Cape, we would like to know how then this maize crop size is going to change if rainfall changes by 1% ceteris paribus. Or alternatively, as we are currently faced with the COVID-19 pandemic, we also want to know how the investment spending in the economy is going to change if the central bank changes the interest rate by 1% ceteris paribus. The list of examples is endless. However, in each case, we will be examining how responsive is one variable to a change in another variable. This is what elasticity is all about. Therefore, elasticity is formally defined as the percentage change in a dependent variable as a result of a 1% change in the independent variable, ceteris paribus. Thus, the elasticity coefficient is simply found by dividing the percentage change in the dependent variable by the percentage change in the independent variable. In the study of economics, there are different types of elasticities. All of these elasticities measure the responsiveness of the change in one variable following a 1% change in the other variable, ceteris paribus. For this course, we will focus on 4 types of elasticities, namely price elasticity of demand, income elasticity of demand, cross elasticity of demand, and price elasticity of supply. The price elasticity of demand is the most important of these elasticities, in which we will spend more time on, and then thereafter, with the understanding of price elasticity of demand, we will discuss other demand elasticities and the price elasticity of supply. From the study of week 3 content, you learned different ways of expressing market demand. In symbols, market demand for a good in a particular period is expressed as a function of the price of good X, the price of related goods, the income of consumers, taste and preferences, the number of households, as well as other factors that affect quantity demanded, as reflected by the expression QD is a function of PX, PG, Y, T, N, and other factors. The price elasticity of demand measures the sensitivity or responsiveness of quantity demanded if the price of the product changes by 1% ceteris paribus. That is, the price elasticity of demand is more focused on the relationship between quantity demanded and the price of the product ceteris paribus. Formally defined, the price elasticity of demand is the percentage change in the quantity demanded if the price of the product changes by 1%, ceteris paribus. The coefficient for price elasticity of demand is found by dividing the percentage change in the quantity demanded of a product by the percentage change in the price of the product. For example, if the price of a product increased by 6%, ceteris paribus, with the resultant decrease in quantity demanded of 18%, then the elasticity coefficient will be equal to 3%. This is just simply found by dividing 18% divided by 6%, and that you get a negative 3%. The 3% price elasticity coefficient means for every 1% increase in the price of the product, quantity demanded decreased by 3%. To illustrate the importance of the price elasticity of demand concept in our analysis, let us examine the magnitude of the changes in quantity demanded graphically. Recall from our previous lessons that when inputs to the production process becomes cheaper, suppliers will want to supply more goods at each price level than before, hence the supply curve will shift to the right or downwards, leading to a decrease in the price and an increase in quantity exchanged. This is exactly what is reflected in figure 5.1. However, the difference between graph A and graph B is that in graph A, the demand curve is relatively flatter, whilst the demand curve in graph B is relatively steeper. From this figure, we can observe that the sensitivity of the quantity demand to a change in price depend on the slope of the demand curve. That is, with a relatively elastic or flatter demand curve, a small change in the price of the product will cause a bigger or more than proportional change in quantity demanded, as shown in A. Whereas with a relatively inelastic or steeper demand curve, a larger change in the price of the product will lead to a smaller or less than proportional change in quantity demand. Thus, knowledge about the slope of the demand curve is important in economic decision making. Consider a profit maximizing firm that needs to adjust the price of their product. If these firm executives knew the sensitivity of quantity demand to a price change, then they will be able to make a strategic and informed decision about their business. There are some important aspects and implications of the price elasticity of demand concept that we need to understand from the onset, and these are: firstly, elasticity is calculated using percentages changes, not absolute values. Hence, the units in which prices or quantities are measured does not affect the outcome or results. For example, whether the price is expressed in monetary terms, e.g. rands, pounds, yens, euros, pullers, nor the quantity is expressed in kilos, boxes, or bags, that does not affect the elasticity coefficient as well as its interpretation. The elasticity coefficient is simply the ratio of the percentage change in quantity demand to the percentage change in the price. Secondly, the price elasticity of demand coefficient outline how people react to changes in the price of different goods and services. Since it is in percentage terms, then we can simply compare how people react to changes in prices of commodities such as meat, bread, petrol, cars, pens, amongst others, but not if the values were in absolute terms. We could not be able to compare these commodities. Let us use an example where we consider two products, that is cars and bread. If the price of this product change by 1 rand, the change on quantity demanded on each product will be different. This is simply because the price of a car is approximately 100,000 and is far greater than the price of a loaf of bread, which is approximately 15 rand. Therefore, we cannot compare absolute quantity changes, rather we compare relative changes. Thirdly, the price elasticity of demand coefficient will always yield a negative value, since there is a negative relationship between the price and quantity demand. In this course, for any interpretation of price elasticity of demand, we will ignore the negative sign and concentrate on the absolute value of the price elasticity of demand, since the negative sign just illustrates the negative relationship between price and quantity demand. For example, if the price elasticity of demand for bread is 3%, then a 1% increase in the price of bread will lead to a 3% decrease in the quantity of bread demanded, and the reverse is true. The price elasticity of demand is calculated using two formulas. The first method is known as the point elasticity formula, normally applicable when there are small price changes. Recall that the elasticity coefficient is calculated as the percentage change in quantity demanded divided by the percentage change in the price. Therefore, if we denote quantity demanded by QD, price of the product by P, and the change by delta, then we can simplify the elasticity formula as follows, where the price elasticity is equal to the percentage change in quantity demand divided by the percentage change in the price. If we expand the numerator or the denominator of this equation, you will find out that you have, in the numerator, you have the change in quantity demand divided by QD multiplied by 100, whilst in the denominator you have a change in P divided by the price multiplied by 100. And then you can further manipulate this equation by cancelling out the hundreds, and after cancelling out the hundreds you can then remove the division sign, and then you end up with the change in quantity demand divided by the change in price multiplied by P over QD. Please do perform this manipulation on your own to check if you fully understand how the final answer was obtained. Looking at the simplified formula for price elasticity of demand we have derived, you will notice that the formula has two important parts. The first part shows the inverse of the slope of the linear demand curve, whilst the second part reflects the ratio of prices to quantity at any point along the curve, hence the name point elasticity. Let us use an example to calculate price elasticity of demand using the point method. Since the ratio of the price to quantity demand changes along the demand curve whilst the inverse of the slope remains constant, this implies that the price elasticity of demand at any point on the demand curve will be different. Using the values from the figure in the slide, the inverse of the slope is equal to a constant value of -2. which is found by dividing -20 divided by 10. This value does not change along the curve. However, the price to quantity ratio changes. Therefore, if we calculate the price elasticity of demand at a point such as A, we will obtain a coefficient of infinity. Right? Since any number divided by 0, the answer will be infinite. If we calculate it at a point such as B, we will obtain a coefficient of -4. If we calculate it at a point such as C, we will obtain a coefficient of -1. If we calculate it at a point such as D, we will obtain a coefficient of 0.25 or a quarter. And finally, if we calculate it at a point such as E, we will obtain a coefficient of 0. Since 0 divided by anything, the answer is 0. From these calculations, we know that as we move downwards and to the right from point A, the elasticity coefficient falls. Furthermore, in the middle of the curve, the elasticity coefficient is equal to 1. To the left of this, the coefficient is greater than 1, and to the right, the coefficient is less than 1. Remember, this is in absolute terms. Although the calculations we have done are technically correct, in practice only a part of the demand curve is encountered. Hence, it is highly unlikely that you will ever find the situation where prices fall to 0 or rise so high that the quantity demanded will be equal to 0. Let us now consider another example where only a part of the demand curve is encountered. Suppose at the price of 48 Rand, quantity demanded of beef is equal to 2000 kilograms. Then if the price of beef falls to 36 Rand, then the quantity demanded of beef would increase to 4000 kilograms of beef. Now, we are being asked to calculate the price elasticity of demand using the point method. The inverse of the slope in this example is equal to a -1/6, which is found by dividing -2 divided by 12. Remember, this value remains constant along the curve. However, in terms of the price to quantity demanded, which point should we consider? If we use the first point, we will obtain a price elasticity of -4. Whilst if we use the second point, we will obtain a coefficient of -1.5 or 1.5. These coefficients obtained from the 2 points along the same demand curve are different. But then, which one of the two is the correct point elasticity of demand? The answer depends on which point we use as the basis for calculation. However, we can eliminate this dilemma on the calculation of price elasticity of demand by considering the average of the 2 points or by using the arc or elasticity method or the midpoint elasticity method. The second method of calculating price elasticity of demand is called the midpoint or arc method. This method compares 2 points on a demand curve. It is normally used when there are large changes in prices. The formula for calculating price elasticity based on the arc method is the same as the one that is used for point elasticity. However, for arc or midpoint, instead of just using one price and quantity values for the ratio of price to quantity demanded, this method uses the average of the two prices and two quantities in the calculation of the elasticity coefficient. In simple words, the arc method eliminates the dilemma of selecting the correct point by calculating a point elasticity in the middle of the 2 points. Let us conclude the calculation of price elasticity of demand by an example using the ARC method. Suppose the price of a product falls from 10 Rand to 8 Rand and quantity demanded increase from 17 to 19 units. Using the midpoint method, the price elasticity of demand is equal to, remember the first thing we do is we should reflect our equation, right? Which is the price elasticity of demand using the ARC method is equal to Q2 minus Q1 divided by Q1 plus Q2 divided by P2 minus P1 over P1 plus P2. And then we substitute our values into the equation. After substituting our values, we do the manipulation, and then we find an answer of minus half. Please go through the examples in box 5.2 as well as in the exercise book to further your understanding in calculating price elasticity of demand using both the arc and the point method.